Okay, so this is a new chapter now. We have already finished the carbon compounds. So we are going to start with redox reaction. There are many parts of this, so I go slowly. Today I just do a certain part only first, okay? We go very slowly because it's a very important chapter for paper 1 and paper 2. Paper 3 is not always asked. Okay, sometimes they do ask, okay? But it's sure essay question for paper 2, either structure or essay. One of it will definitely come. And objective, sometimes there'll be about 4 questions. 3 to 4 questions for this chapter. Okay, out of 50, yeah? Okay, we start first. Ready, yeah? Okay, so let's look at the word redox. Our title is redox reaction. The word RED and ox. Can you see now? RED actually is reduction and OX is oxidation. So this redox reaction means we have oxidation and reduction both taking place at the same time. Can you see now? Redox reaction, oxidation and reduction both taking place at the same time. So let's look at number 1 first. Okay, all right. Okay, we are not going to do B and C, but I just tell you first. So today we only concentrate, let me see first. Today we only concentrate on the first part only. Okay, let's have a look first. First, note it down. Redox reaction can be defined as a reaction that involves an oxidation. Oxidation and reduction which occurs at the same time. Or the word is simultaneously. Okay, note it down first. Write it down. Redox reaction is a reaction that involves an oxidation and reduction.
You just double confirm the AOXY.
OXID. Oh, sorry, oxidation.
Yeah.
Sorry. Okay, thank you. All right. Sorry, small a. Oxidation. Thank you. And involves an oxidation and reduction. Okay. B, you just write the answer, but this one I do next lesson on Thursday. The second part of redox involves transfer of electrons. This one we do next lesson. Transfer of electrons, which involves either a loss, LOSS, kehilangan electron, or gain of electron. This one I'm not going to touch it today because we have other things to do today. All right. And then the third one also, next lesson also, a change which is either an increase or a decrease in the oxidation number. So we're only going to touch on A today. All right. Okay. Either increase or decrease in the oxidation number. Oxidation number also I'll tell you next lesson. Don't worry about all it now. Just today we're going to learn this part first. Oxidation and reduction can be defined in terms of loss or gain. Either you accept oxygen or you release what? Oxygen. Loss or gain of oxygen. Right on. A, loss or gain of oxygen. I zoom in a bit. Okay. One more we're going to learn today also, loss. Either you release or you lose or you gain of hydrogen. Okay, C and D you can leave it also. Because we'll do that next lesson. All right, I only want you to concentrate on these two today. Okay, we're looking at the loss or gain of oxygen and loss or gain of hydrogen. Okay, so let's go for this one first today. This is what we're learning today. The meaning of oxidation reduction in terms of loss or gain. All right, so put down oxidation is a process of gaining oxygen. Write that down first. Oxidation is a process, you gain oxygen, you receive oxygen. Gain means receive. You can even put the word receive oxygen. Reduction is the process of losing oxygen. So remember that. Oxidation, you gain oxygen. Reduction, you lose oxygen. Okay, let's look at one example here. All right, I'm going to give you there 3 examples for you to try. And after that, you're going to do another 2 more examples here. You see? All right? Okay. Then you cover all the oxidation part for oxygen. Okay, let's try this one first. Okay, I make it smaller so all of you can see. Okay. So it's something like this. Okay, ready? So let's look at the first part first. Okay. This is a redox reaction. How you know it's redox? Okay, let's have a look first. You see, I want you to concentrate. Magnesium, I put an arrow like that. Magnesium becoming MgO. I mean, magnesium has gained oxygen. Correct? Huh? Okay. And the other one is PbO becoming Pb. PbO loses oxygen. Can you see? Becomes Pb. So it's a redox because this magnesium is gaining oxygen and PbO is losing oxygen. So this is a redox reaction. Because oxidation and reduction both taking place in the same reaction. You understand or not? All right? We have not learned this so far in what we have learned so far. But now we're coming to the new part. Huh? Okay. And this part of redox, I'm telling you, is a continuation. Once you learn this, when you go for your A levels or you go for your STPM or matriculation or whatever, all right, or your Cambridge levels, okay, the foundation of what you learn here will be applied there. Your lecturer is not going to explain all this, what you're learning now. He assumes that you have all this knowledge now, and then he just understand. Huh? So the foundation is very important. Okay, ready? Huh? So let's go first one first. We'll do one row like that. Huh? I'll do the first one, then the second one and third one you do yourself. We'll do and I will test afterwards. So first one, magnesium gains oxygen, write down, because Mg becomes MgO. And lead, we don't say lead oxide. Lead is special case. You must put lead 2 oxide, PbO. Pb is 2 plus, O is 2 minus, so it's PbO. Lead 2 oxide loses oxygen. Okay, then what we say here, magnesium, okay, I want you to write this word. Magnesium is oxidized. Write down first. Oxidise. To form magnesium oxide because it's gain oxygen. So the word is oxidize. Lead 2 oxide is reduced. The word is reduced to form lead. See, PbO becomes Pb. You lose oxygen, so it's reduction. So you reduce. Okay. Next, what type of reaction is this? All right. So this is oxidation because you have gained oxygen. So oxidation. Oxidation. PbO losing oxygen to become Pb. So this is a reduction reaction. So type of reaction, oxidation or reduction. You have learned so many types of reaction, isn't it? Hydrogenation, dehydration, remember, esterification, neutralization. This is another reaction in chemistry. Oxidation or reduction. You gain oxygen, oxidation. You lose oxygen, reduction. Very clear cut. Okay. Then we have 2 agents coming in. All right? Okay, the agents will be from here. Okay, I'm going to say the agents will be from here. One of this. The reactants, one is oxidizing, another one is reducing agent. One is oxidizing agent, OA, I put short form. Another one is reducing agent. Okay, how to know? Okay, so very simple. You see here, I just use this one. Can you see? Mg is becoming MgO. Is that correct? So this process is oxidation. One, you can write that down first. Okay. And then PbO becoming Pb. This process is reduction. So I'm going to put RED, correct? So this is redox because it's losing oxygen. Okay, so you can see how to identify the oxidizing agent and reducing agent. The oxidizing reducing agent will be one of this on your left hand side. They give you 2. One is oxidizing, one is reducing agent. Okay, you can see here. PbO has been reduced to Pb. So Mg must be your reducing agent because PbO reacted with this, it became reduced. Can you see now? All right, PbO reacted with Mg and it became reduced to Pb. So Mg must be reducing agent. So write down here, magnesium acts as a reducing agent. Please note that down. Huh? Magnesium acts as a reducing agent. Okay, magnesium acts as a reducing agent. Why? Because it has reduced PbO to Pb. That's how you know magnesium acts as a reducing agent. Okay, now you see this reaction now. Magnesium becoming MgO. Can you see now? Magnesium becoming MgO. So magnesium was oxidized to form magnesium oxide. So this must be your oxidizing agent because magnesium reacted with this and it became oxidized. Can you follow me? All right, I repeat again, but this one is a bit quite important. These two reacted. Okay, so one is oxidizing agent, one is reducing. So you can see PbO underwent reduction. So this must be your reducing agent because when PbO reacted with magnesium, it became reduced. Okay, so Mg is your reducing agent. And then here, you can see Mg became MgO. It was oxidized, correct? So this must be oxidizing agent because Mg added to this, Mg was oxidized. So here, this side here, all right, write it down first. PbO acts as a what agent? Okay, we will clear first, right? So here I put on magnesium acts as reducing agent, lead 2 oxide acts as an oxidizing agent. Okay, then the last part. Why is it reducing agent? Because magnesium reduces, right? In words, I want to write in words. Lead 2 oxide, put Roman numerals 2. Lead 2 oxide to become lead. That's why it's a reducing agent. Okay, and then here, lead 2 oxide is an oxidizing agent. Why? Because it oxidizes, the word oxidizes, O-X-I-D-I-S-E-S. Magnesium to form magnesium oxide. So in this topic, you have to know which is your oxidizing, which is your reducing, what is oxidized, what is reduced. That's all you have to know. What is oxidized, what is reduced. Okay, so this is what we're learning. This is the basic thing you have to know first. Okay, let's try this one. You try for me now first. Okay. All right, so same thing again. What you do now is here, you know CuO is becoming Cu. So what type of reaction? This is, you lose oxygen. So this is reduction, RED. Okay, put that down first. And then zinc becoming zinc oxide. Can you see? You gain oxygen. So this is oxidation. You combine RED and OX becomes redox reaction. Okay, now answer. Follow the same as the first one. You do number 2 and number 3 first. Okay, you try it first. Make it smaller in size so you can see. Okay, try that first. What process? You must know what is oxidizing, what is reducing, and what does it do? What does the oxidizing agent do? What does the reducing agent do? Jaden, are you finished, Jaden?
Yes.
Okay, we'll try. I'll just give them another 1 more minute. Then, okay, we'll try. This is the foundation. If you understand this, then you can carry on to the other parts of the redox reaction. So there's for 6 parts, redox reaction part 1 until part 6. It's a very wide chapter. Okay, ready? Okay, Jaden, try. Zinc gains
Oxygen.
Okay, you're going to give me the whole answer for everything, All right, okay. Zinc gains oxygen.
No problem.
Copper 2 oxide?
Loses oxygen.
Loses oxygen. Okay, very good. Okay, second one. Zinc is what?
Oxidized.
Oxidized. Very good. To zinc oxide. So now you can see from here. You see, you must use the correct word. So copper 2 oxide. Copper
is reduced.
Just one more thing. Copper, you cannot say copper oxide. You must mention copper 2 because there's also copper 1. So you must mention copper 2. The famous way you must put Roman numerals. Lead 2 oxide, copper 2 oxide, and all the other transition metal oxide. Understand? Okay. Copper 2 oxide is what?
Reduced.
Reduced. Okay. What process is this, Viren?
Oxidation.
Oxidation process. You can see because zinc gains oxygen. What process is this?
Reduction.
Okay, wait. Somebody's asking me a question. What's the question? No question, Okay. Then zinc acts as what agent?
Reducing.
Reducing, because it reduces copper to oxide to copper, correct? So zinc is a reducing agent. Because why? When zinc was added to copper to oxide became Cu. So zinc is a reducing agent. Copper to oxide,
Oxidizing.
oxidizing agent, as oxidizing, because it oxidizes zinc to, okay. And the last one, why is it oxidizing or reducing? So zinc reduces what?
Copper to oxide.
Right, in words, copper to oxide to copper. And copper to oxide is an oxidizing agent because it what? It oxidizes zinc to zinc oxide. Simple, huh? Okay. See, you know why I'm doing this? I want you to do this. After this, you're going to write yourself. Okay, the main things like this. You understand? So it's just a practice. They won't guide you like this in the SPM. They just give you something like this, explain. Yes. Understand? Okay, we're going to do it now. Right. Try number 3 first. Let them try first. I'm going to, let me see, who shall I call? Okay, I'm going to call to explain. Okay, let's see first. Carlo, are you ready, Carlo? Can you hear me, Carlo?
Yeah.
Okay, all right, you're going to explain for me first. What is NH3? Satish, NH3 is ammonia, Satish. Okay, NH3 is ammonia. Okay. Just give them about 2 minutes, Carlo, then you explain.
Okay.
Have you completed number 3, Carlo?
Still doing.
Okay, we try first. In the exam, they won't draw this arrow like that for you. They won't draw. They only put this plus this, forming this plus this. Okay, I just did it. Okay, to guide you. If you want, you can put the reduction and oxidation on top of the arrow and below. Okay, shall we? Number 3, Okay. Kalau try, first one.
Gains oxygen.
Okay, calcium gains oxygen, betul, because calcium becoming calcium oxide. Okay, carry on. Al2O3 is known as aluminium oxide. So aluminium oxide
Loses oxygen.
loses oxygen. Okay. So what's the second statement?
Calcium is oxidized.
Oxidized, Oxidised, okay, to calcium oxide. Aluminium oxide is
Reduced.
reduced to aluminium. Okay, good. Right. So what process is this?
Oxidation.
Oxidation. Good. And what process is this?
Reduction.
So the process is oxidation and reduction. Okay. So now we identify the oxidizing agent and reducing agent. One of it is OA, one is RA, reducing. Okay, you can see here, this is oxidized. So calcium acts as what agent? Hello?
Reducing
Reducing,
agent.
because when calcium was added to Al2O3, Al2O3 was reduced. So calcium is a reducing agent. So aluminium oxide is what agent?
Oxidizing agent.
So why is calcium reducing agent? It reduces what? What's the word? Write it in words now. Reduces what? Here. Hello? Are you there, hello?
Oh, aluminium oxide.
Aluminium oxide to aluminium. That's why, okay? is calcium the reducing agent? Okay. Aluminum oxide, what's the word?
Oxidizes.
Okay, calcium to calcium oxide. Huh? Okay, we have done that already. So now the next thing is, okay, I'm not going to guide you in anything here. You're just going to write for me. Huh? Okay, we go one by one. Huh? I'll guide you. Okay, ready? So, is this redox or not? Sean, can you, Sean doesn't have a microphone. Huh?
Hey, God.
Sean, you have. Okay. Sorry, Sean. I thought.
Buy already.
Okay. Is this redox, Sean?
Yes, redox.
How do you know it's redox?
Because magnesium become magnesium oxide.
Okay,
through
magnesium is
oxidation.
oxidized. So it's magnesium is oxidized to magnesium oxide. Okay, then
Yeah. Then
Then?
tin
tin oxide.
tin oxide becomes
Or
tin.
we call it
to,
actually tin also must put tin 2 oxide. You know,
tin 2 oxide. Yeah. Become
what?
tin 2 because of reduction.
Tin 2 oxide became tin because of reduction. Okay, so it's a redox. So explain the redox reaction. They did okay. Anyway, write down number 1 first. This reaction is a redox reaction. Okay, just write number 1 first. Okay, put number 1. This reaction is a redox reaction. Never mind, we write it. No problem. Yeah. So now we explain. Okay, magnesium is what? Oxidized to magnesium oxide. Write that down. Second point. Magnesium is oxidized to magnesium oxide. Put bracket oxidation. So no need to write another line. Magnesium is oxidized to magnesium oxide. Put bracket there, oxidation. The process is oxidation. I want you to write in words, all in words. Because in SPM, they want to describe in words, Okay. Then we go for this one. This one you put down tin, T-I-N. BM is tannum. Okay, but in English, we call it tin. Tin, Roman numerals, you put 2 there. Tin 2 oxide is reduced to tin. Tin 2 oxide is reduced to tin. Okay, put bracket there. What process it is? Reduction. Okay, now the last thing I need is, which one is oxidizing, which one is reducing? Okay, Jaing, continue, Jaing. Which one is my oxidizing agent here? Jaing, are you here, Jaing? Jaing is not here. Who shall I ask? Okay, Yongsin, you try Yongsin? Okay, now which one is my oxidizing, which is my reducing agent? Tell me, Yongsin.
Magnesium is reducing agent.
Okay, well done. Because magnesium tin 2 oxide was reduced. Okay, so write that down. Magnesium is reducing agent. Very good, Yongsin. And continue. Which one is my oxidizing agent?
Tin is the
No, not tin. This one. What do you call this?
tin 2 oxide.
Tin 2 oxide. Very good. TiN. Tin 2 oxide is my oxidizing agent. No need to explain why, we already know. So that's all they want when they ask you to describe. Okay. Well done, Okay, we go second one. All right, try first. Follow the same template I gave you first. Okay. Is this redox or not? Write that down first. I'm going to ask Alim. Alim, your turn, Alim. Okay, Alim is here, isn't it? Alim is here. Okay, I'll try. Avril, your turn is coming next after this, Avril. All right. Try first. What is oxidized? What is reduced? What is the name of the process? What is oxidizing agent? What reducing? That's all, Chuko. Go slowly, no, you. Okay. Alim, are you ready, Alim? Don't have a microphone, Alim. Alim, you ready? You have a microphone, Alim? No, you have no microphone. Okay, then I ask someone because I want the others to hear. No problem. Okay, Avril, are you ready, Avril? Avril, are you...
Yes.
Okay, try, okay. Shoot. What's the first one? Is
This
it a redox reaction? Is it a redox reaction? Okay, write
Yes.
down. This is a redox reaction. Okay, number 2, good. Okay. Why you say redox now? Okay, explain to me.
Zinc is oxidized to zinc oxide.
Okay, very good. Second point, zinc is oxidized to zinc oxide. Okay. All right, good. Third point.
Iron 2 oxide is
Well done.
Yes.
Because iron, you cannot say iron oxide because iron got iron 2 and iron 3. But you can see from here, Fe is 2 plus, O is 2 minus. So this is iron 2 oxide. So what she mentioned, is iron 2 oxide. Well done, April. Iron 2 oxide is what?
reduced to iron.
Is reduced to iron. That's why the redox reaction. Okay. Wait, just now you say zinc is oxidized to zinc oxide, isn't it? Okay, put bracket there, put what type of reaction? Oxidation, all of you. And then number 3, she said iron 2 oxide is reduced to iron, so put bracket there, reduction. Well done. Okay, now we only got 2 more things. Identify the oxidizing agent and reducing agent. Okay, we'll try with Alicia. Alicia, continue. Which is my oxidizing and which is my reducing, Alicia?
Iron 2 oxide is the oxidizing agent.
Okay, very good. Iron 2 oxide. Everything I will write in words. Don't go put chemical formula. Iron 2 oxide is the oxidizing agent. No need to explain why, we know already. Okay. And what is the reducing agent?
Zinc.
Zinc is a reducing agent. That's all. So that's all they want in SPM. Exactly, huh? Okay, good. Okay, so settle with that today. After that, we do, okay. Now we go for another type of redox involving hydrogen. That's not only oxygen. Now involving hydrogen. Because this one also in the syllabus. If in the syllabus, they can ask, you cannot question them, huh? Okay. So now it's a reverse, Just now oxidation is you gain oxygen. Now it's for hydrogen is a reverse. Oxidation, you lose hydrogen. See the reverse, Just now oxidation, you gain oxygen. Now we are talking of hydrogen only. You gain hydrogen, you lose hydrogen. Reduction, you gain hydrogen. So let's check and see first, Okay, I'll just show you this first. You can see H2S is hydrogen sulfide. The name is given, hydrogen sulfide. This is your H2S. Okay, and then Cl2 is known as chlorine, or chlorine gas also can. This is hydrogen chloride gas. Please note it down. This hydrogen chloride. It's not hydrochloric acid. Hydrochloric will be AQ down there. Hydrogen chloride, and this S is the sulfur. Okay, so I give you the 4 products, 2 reactants, 2 products. So you can see from here, H2S is becoming S. That means it has lost hydrogen. Can you see that? I put here, so H2S becomes S. Sulfur, okay, it has lost hydrogen. So what process? This definitely must be oxidation. So this process must be oxidation. You see that? All right. And whereas chlorine, you see, chlorine becomes HCl. You see, it has gained hydrogen. Can you see now? From Cl to, you see, gain hydrogen. So this must be reduction, RE. Okay. We're talking in terms of hydrogen now. Okay, so now try. All right. I'll guide the first one for you. After you can do the second one. Hydrogen sulfide, H2S, loses what? Hydrogen. You can see from here, okay, write down, loses hydrogen. Okay, and then chlorine gains hydrogen. So now we're only talking in terms of hydrogen. Nothing to do with oxygen, Okay. So if it loses, we know it's reduction. So hydrogen, this is oxidation, and then you lose, So hydrogen sulfide is oxidized to sulfur. Right in words. S is sulfur. Jaying now only entering, Jaying, Right? Hydrogen sulfide is oxidized to sulfur. Okay, Cl2 chlorine, can you see, we know it's reduction because, it has gain hydrogen. So chlorine is reduced to hydrogen chloride. Hydrogen chloride. Okay. So we know this is oxidizer. So put down an oxidation process. Type of reaction is oxidation, because it has lost hydrogen. Okay. This one is you have gained hydrogen, so it is a reduction process. Okay. So from here you can see here. That's why I write this, so you can identify your oxidizing and reducing agent. This was oxidized. Correct or not? This was oxidized. So this chlorine must be your oxidizing agent. Because H2S was oxidized. Okay, because it underwent oxidation. So chlorine put down. Here chlorine acts as your oxidizing agent. And then here you can see hydrogen sulfide. Chlorine underwent reduction. So hydrogen sulfide is your reducing agent. Okay, let me clear the drawing. Then we go to the last part. Okay. Why is it reducing agent? It reduces, put down first, okay, practice it. Chlorine, it reduces chlorine to form hydrogen chloride. So afterwards, you're going to explain in words. I don't give you anything, I just give the equation. And why is chlorine oxidizing agent? It oxidizes hydrogen sulfide, right? The spelling there, hydrogen sulfide to sulfur, to form sulfur. S-U-L-P-H-U-R. Okay. All right. Now, we will do number 2 now. Okay, number 2. All right, I guide you here. The only thing I'm going to put here is I'm going to put the process. Okay. H2O becoming, that means what? You lose hydrogen. Okay, when you lose hydrogen, this is oxidation. When you gain hydrogen, can you see that? When you gain hydrogen, for F2 become HF, you again. So this is reduction. Okay, I've guided you here. So now you can complete everything. Okay. H2O is water, F2 is fluorine. Fluorine is a gas. O2 is oxygen. HF is known as hydrogen fluoride. F-L-U-O-R-I-D-E, hydrogen fluoride. Right.
Teacher,
Yes.
but the HF is in aqueous state, so isn't it supposed to be an acid?
Where, which one? HF?
Yeah, it's AQ, so is it an acid?
Oh, okay, okay. That means hydrofluoric. Never mind, you just put hydrogen fluoride. Put hydrofluoric acid, then you get confused. Never mind. Just put hydrogen fluoride. The important thing, I want you to identify which is your oxidizing, which is reducing agent, what is oxidized, what is reduced. That's all they want in SPM. They'll always give you 2 reactants, you know, they won't give you 3 reactants. Is Elisa here today? Elisa is here. Oh, Elisa is here. Okay. Elisa, you're going to explain, Elisa? Huh? Are you ready, Elisa?
Yeah.
Almost. Okay, we just give them 1 more minute, Elisa. Huh? Then you
Okay.
just give them another 1 more minute. On Thursday, we'll go to the transfer of electrons and oxidation number. Okay, are you all ready? All right. There's another 30 seconds more, and then we'll try. Okay. Okay, Elisa, try. Water loses what?
Hydrogen.
Water loses hydrogen, you can see. Okay, water loses hydrogen. Fluorine is F2. What? Gains?
Hydrogen.
So now we're talking in terms of hydrogen only. Good. Okay. So when you lose hydrogen, of course, it's oxidation. So water is oxidized to what?
Oxygen.
Oxygen. O2 is oxygen. Oxygen gas accept. Okay, and then fluorine is F2 is reduced to, now you just put hydrogen fluoride, all of you. Okay. Fluorine is reduced to hydrogen fluoride. 2 words, hydrogen fluoride. Okay, so we know this is oxidation. So oxidize means, so what process, Alisa? This one?
Oxidation.
Oxidation process, well done. And what process is this?
Reduction.
Because you gain, all right, hydrogen, so reduction. Just the exact opposite of oxygen for redox. Okay. So now we have here, you see from here, this underwent reduction. So obviously water must be your reducing.
Reducing agent.
Okay. And then fluorine,
Oxidizing agent.
oxidizing, because you can see water underwent oxidation. So why is it reducing agent? Water reduces what?
Fluorine to hydrogen fluoride.
Okay, fluorine, fluorine. You can say fluorine or fluorine gas also can. Fluorine, I-N-E, F-L-U-R-I-N-E, to hydrogen fluoride. And why is fluorine an oxidizing agent? It oxidizes what?
Water to oxygen.
Water to oxygen. Very simple. Okay. All right. Done, Okay, now you're going to explain in words now. But from here, number 1 until number 8, all explain. That's all for today. Ready, Okay, we're going to try now. Double check first. I'll give you a hint, all right? I'll just draw the arrow for you to guide some of you, okay? This is coming here, all right? And this BR. So this does not involve oxygen at all. It is what we just learned just now. Okay? So this one is you lose hydrogen. When you lose hydrogen is oxidation. This one you gain hydrogen, so this is reduction. Okay. This will help you, Okay. NH3 is ammonia. Please remember that. Ammonia gas. This is bromine. This is nitrogen gas, N2, and this is HBr, hydrogen bromide. I give you the 4 words. So when you describe, you can put it in words. Always remember, NH3 is ammonia gas. It's not ammonium, okay? Ammonia. All right, is this redox? Okay, write down first. This is a redox reaction. Follow the template, same thing. Okay, number 1, this is a redox reaction. How you know? Because there's oxidation reduction taking place. Okay, now, what is oxidized? Okay, let's see. Okay, I'm going to call, never mind, just try, don't be scared, All right. Celine, want to try now, Celine? Celine, are you ready?
Yes.
Okay, you try, Celine?
Ammonia
Guys.
is oxidized to nitrogen gas.
Okay, very good. Okay, number 2. Ammonia is oxidized to nitrogen gas. Nitrogen also they accept, Okay. Then?
Bromine is reduced to hydrogen bromide.
Okay, bromine is reduced to hydrogen bromide. Okay, so just now number 2, ammonia is oxidized. So you put bracket there, OX, oxidation, or oxidation right in detail. This one, bromine is reduced, you said, so put down reduction. Okay. Last 2 is identify oxidizing and reducing. Okay, Celine, continue.
Ammonia is reducing agent.
Ammonia is reducing agent. Well done. Last one.
Bromine is oxidizing agent.
Yeah, you see? Well done. Very good. You see? That's all. Okay. Try number 2 now. Okay, Al-Padam. Try number 2 now. Okay, number 2. Okay, you can see, there are 2 reactants but 3 products. Nothing to worry. Okay, now we can gabung, Okay, hydrogen and oxygen also you can do together. Okay, let's see first. I'm going to guide you, All right. You see here, I'm going to put like this. And from here, I'm going to go here. Okay, right. Okay, follow the two arrows. Exam, they won't give the arrow, huh? You draw yourself, you know. I need 5 points. Is this redox? Answer first. Second thing, what is oxidized? 1 more mark. What is reduced? 1 more mark. What is my oxidizing agent? What is 5 points I need. Try first. Let me see who shall I call, huh? Alfred, want to try Alfred? You got microphone or not, Alfred? Alfred, number 2, Alfred. Okay, try. Can you hear me, Alfred?
Yes, I can hear you.
You can, huh? Okay, you try? Okay, you complete first. Again, please take down the attendance, those who didn't attend today. All right. I think Terence is not here today. And for Val also, please update those not present so the others are automatically considered as present. Okay, are you ready, Alfred? Alfred, try, Alfred? Okay, number 1 first. Is this redox? Okay, look at this one. This one, you're losing hydrogen. When you lose hydrogen, it is oxidation. Here, you lose oxygen. Can you see now? You lose oxygen. So this is, you can combine like that also can, you know. One involving hydrogen, one involving oxygen. Also can, nothing difficult. Can you see that? All right. Here you gain, here you lose hydrogen, here you lose oxygen. Okay, Alfred, try Alfred. Are you ready, Alfred? Not sure. Okay. Satish, try Satish. Hello, Satish, are you there?
Ammonia loses hydrogen.
No, wait. Number 1, is this redox or not?
Yes.
Okay, write on number 1 first. Follow the template. Okay. This is a redox reaction. Yeah, good. Because there's oxidation and reduction, you know, you can see here. Okay. How to know? Okay, put number 2 now. Okay. Continue, Satish.
Ammonia loses hydrogen.
Ammonia loses hydrogen. Yes. Like that, put oxidation. Loss of hydrogen, oxidation. Okay. Continue. Third one.
Ammonia is oxidized to nitrogen.
No, okay, that's the same thing. Ammonia is oxidized to nitrogen because it loses hydrogen, isn't it? Okay, doesn't matter. That is your second point. Ammonia is oxidized to nitrogen because it loses hydrogen. Okay. Undergoes oxidation, all right, to nitrogen because it loses oxygen. Okay, no problem. Okay, what about this? Next one.
Ammonia acts as a reducing agent.
No, before that, this one first.
Copper 2 oxide loses oxygen.
Okay, copper 2 oxide is reduced to copper, correct, isn't it? Because it loses oxygen. Okay, I repeat again. Number 2 will be ammonia is oxidized to nitrogen. Just say that also, you know. Put bracket there, loses hydrogen. Okay. One, copper 2 oxide. CuO is copper 2 oxide. You say copper oxide wrong, Copper 2 oxide is reduced to copper because it loses what? Oxygen. So we've explained what is reduced, what is oxidized. Okay, then comes your last two, OA and RA, which is your oxidizing agent. Satish, continue.
Copper 2 oxide acts as an oxidizing agent.
Very good. CuO or copper 2 oxide is your oxidizing agent because this was oxidized one. Reducing agent?
Ammonia acts as a reducing agent.
Ammonia is the reducing agent. Well done. That's all. 5 points. I only need the 5 points. Okay. One more. We'll try this one now first. Okay. Okay, you see here. All right, I'll guide you. All right. This one is 1. And this one is 1. This one, look and see. It has lost hydrogen. Correct or not? It has lost hydrogen. So when you lose hydrogen, it is oxidation. Oh, it can be both, huh? Wait. Let me see first. When you lose hydrogen, it's also oxidation. This one is what? Okay. This is gaining hydrogen, correct? You see? You gain hydrogen. When you gain hydrogen, it is reduction. Right now, you see it? Oxygen is here, now you gain hydrogen. You gain hydrogen, here you lose hydrogen. Okay, so involving hydrogen. Okay, shoot. Yishuan, want to try Yishuan? Yishuan? Try first, huh? Tengok sini, you lose hydrogen. Here you gain hydrogen. Are you ready?
Sure, you're asking who?
Yishuan.
Huh?
Asking you lah.
Oh, okay, sorry.
Okay, want to try? Okay, number 1, follow the template, huh? Is this redox?
Yes.
Okay, right on. This is a redox reaction. Okay. This is a redox reaction. Okay, continue.
Okay.
Why is this redox?
Because oxygen is being changed.
No, you don't use that word. You must use either oxidize or reduce. Okay, start with this first. Why is this redox? What is this called?
It's called redox.
What? I don't know. What is HCl called? Because now you must explain all in words and like what the others did, you know.
Oh.
What is this called? HCl is known as what?
Hydrochloric acid.
Chloride. Okay. No. Okay. Can so, but you just put hydrogen chloride.
Okay.
Hydrogen chloride is what?
Is oxidized.
Oxidized to what?
Chlorine.
Chlorine. Why? Why you call it oxidized? Because it's what? It loses what?
It loses
No. It gains what?
charge.
Huh?
Oxygen, sorry. Wait,
No,
what?
no. Try again. HCl now becomes. This one, it loses what? It loses what? Sorry. I repeat again.
It loses
Hydrogen
oxygen.
chloride. Yes. No. Try again. Where got oxygen here?
Nah, the O2.
No. You see, okay, now I guide you. You see HCl here. Now it's Cl2. So obviously it has lost what?
Hydrogen.
Okay, so you say HCl is oxidized to Cl2 to chlorine, or hydrogen chloride is oxidized to chlorine because it loses what? Hydrogen. Yeah?
Yeah.
Then we go for this one. What is this called?
Reduction.
What is this? O2, what do you call it? We describe it
Oxygen.
first. Oxygen is reduced, correct or not?
Yes.
It's reduced to what? What is this thing called?
Water.
Water, okay. Oxygen is reduced to water. Why?
Because it gains.
Because it
hydrogen.
gains one. That's all. That's what I want to see. Well done. Because
Okay.
it gains hydrogen. Okay, huh? Okay, then from here, one is your OA, one is your RA identified. Which is your OA, oxidizing?
OA is chlorine. No. Is it?
Where go chlorine? I told you your oxidizing agent and reducing agent is one of this, you know.
Oh,
This is H.
oxygen.
Oxygen, yes. So oxygen is your oxidizing agent. Is the oxidizing. Wait, somebody's asking me something. Stop playing. All right. Okay. A bit serious, another 10 more minutes only. Okay. So continue, Jason. So oxygen is your oxidizing agent. Okay. Huh? All right. What's the other one? HCl is your what?
Reduction.
No.
Wait.
What agent?
Sorry.
Agent. Oxygen is oxidizing agent. So the HCl must be your
Reduction
what?
agent.
Where got reduction agent? I never told you reduction agent. What should it be?
No man? Or reducing agent, sorry.
Reducing agent, not reduction agent. Huh? All right. Okay. Okay, we go next one. Huh? All right, we'll try one more. Okay, ready? We'll try this one now. Okay. Yu Cheng, are you there, Yu Cheng?
Yes.
Okay, Yu Cheng, your turn now. Huh? Okay, I guide you. Huh?
Yeah.
Okay, I'm going to put like this. And I'm going to put like this. Okay, ready? This one, you're losing oxygen, correct? So this is reduction. This one from CO becomes CO2. You gain oxygen. So this is oxidation. So now it involves oxidation. Oxygen. Okay, are you ready now, Jay?
Yeah.
Okay. Number one, follow. Is this redox?
Yes.
Okay, write down. All of you. This is a redox reaction. Very good. Okay. So now explain.
Iron.
Okay, wait. Okay, I give you a name. This one is
Iron 3.
iron 3 oxide. Okay. What is this CO called?
CO.
What is CO?
Carbon dioxide. Carbon oxide. Carbon oxide.
No, there's no carbon oxide.
Carbon monoxide.
Carbon monoxide. Well done, Adi. Okay.
Okay.
Then this is carbon dioxide. You learn. Carbon monoxide. You don't say carbon oxide. Carbon monoxide.
Okay.
Carbon monoxide is the one that comes off from the car exhaust fumes. Carbon dioxide is you breathe out. Okay, ready? This is iron 3 oxide. You managed to tell that. Very good. Okay. So second point. What's the second point? I want it right in all in words.
Iron 3 oxide.
Right? Carry on.
Is oxidized. Is reduced.
You follow here. Iron 3 oxide.
Yeah.
Used to form what?
To form iron.
Iron. Okay, one more mark. Okay, iron 3 oxide is reduced to form iron. So it's reduction. Okay.
Yeah.
Carbon?
Iron 3 oxide.
No. You already
loses.
Okay. No need.
Okay.
Iron 3 oxide is reduced to iron. Okay. Because it loses oxygen. Okay, good.
Yeah.
Right.
Okay, and
what about this?
carbon monoxide
is
oxidized to carbon dioxide.
Okay, because it gains what?
Yeah. It gains oxygen.
That's it. You got it ready. Then comes your last two, which is your oxidizing agent. Okay, reducing agent. Right.
Carbon monoxide is iron 3 oxide is oxidizing agent.
Okay, very good. Iron 3 oxide is oxidizing agent. Put short form OA also can. Exam write in detail. For today's class, just put OA. Okay, then carbon monoxide, CO is what?
Reducing agent.
Carbon monoxide, I won't write the name. It's reducing agent. Not that difficult, isn't it? All right? Okay. And now you tried your best.
Okay.
Okay, good. Okay, we go one more now. Right? Let's try this one. Okay. Simple. This one very easy one. Okay. So this one you H2O, you gain oxygen. So this is oxidation. Wrong. My arrow is wrong. Sorry, I went wrong. Okay. CO becomes CO2 becomes CO. This one you gain oxygen, so this is oxidation. This one you lose oxygen becomes reduction. Okay. All right. Jaing, your turn, Jaing.
This is a redox reaction.
Okay, number one, this is a redox reaction. Okay, very good. Okay, you know all the names, This is carbon dioxide, this is hydrogen, this is carbon monoxide, this is water. Okay, use all the names. Now explain. Why is this redox?
Carbon dioxide is reduced to carbon monoxide.
Okay, well done. Carbon dioxide is reduced to carbon monoxide. Okay. Next point.
Hydrogen is oxidized to water.
Hydrogen is oxidized to water. Well done. Okay, now your OA and RE.
Carbon dioxide is oxidizing agent.
Yes, carbon dioxide is oxidizing agent. Then
hydrogen is reducing agent.
That's all. Well done, huh? Okay, good. Okay, we go one more. Losing oxygen. Here, gaining oxygen. Adeline, want to try, Adeline? Your turn. Adeline, are you there?
But I haven't do.
Okay, okay, try first. Okay, sorry. This is very simple. You know how to do it, huh? But you must, okay. NO, okay, I gave you the name, huh? NO, and Lynn, I just note it down somewhere. NO is nitrogen monoxide, not nitrogen oxide, huh? Monoxide. Nitrogen, MONOXIDE, yeah? Okay, that one you must know the name. CO is carbon monoxide, that one we know. N2 is nitrogen. CO2 is carbon dioxide. Okay, these are the four names. Huh? NO is nitrogen monoxide. Okay. Check and see. This one, you are losing oxygen. All right. So this is reduction. This one, you gain oxygen. So this is oxidation. Okay, I guided you. Okay, now you try. Never mind, you make mistake, you learn. No? You don't worry. Okay? Okay, we're all learning. Nobody's going to laugh at anybody. Are you ready?
Sure.
Yes?
Okay.
Sure. This type of question usually how many marks?
This one comes up sometimes in the essay. No, it can be 3 marks.
Okay, thank you.
Marks, understand? Okay. Is this redox, Adeline?
Yes.
Okay, write down, all of you. This is a redox reaction. Okay, put bracket, they just put redox reaction number 1. Huh? Okay. Why is this redox? Okay. Use the words. I want you to use the words.
Nitrogen monoxide loses
So
oxygen.
I want to use the word reduce and oxidize. Try again. Huh? Nitrogen monoxide is what? Is
Is
reduce. Because I put the RED in the reduction. So nitrogen monoxide is reduced to what?
nitrogen
Why? Because it what?
loses oxygen.
Okay, very good. Because it loses oxygen. Huh? Okay. Okay. Nitrogen monoxide is reduced to nitrogen because it loses oxygen. Okay. Next one. This is CO. What is this CO called?
Carbon monoxide
Carbon monoxide. What's the word? Is
oxidized
to
carbon dioxide
because it gains what? It gains
oxygen.
Okay, very good. Well done. Now, which is your OA? Oxidation.
Nitrogen monoxide.
Nitrogen monoxide is the oxidizing agent. And then carbon monoxide is the
reducing agent.
Yeah, that's all. Well done, huh? Very good. Okay. You can do it. All right, Alicia. Okay, let's try number 7 now. Okay, finish off 7 and 8 now. It's almost 3 o'clock already. I just give you another 2 more minutes, huh? Okay, you try. Okay, this one, I give you a name again. This is iron 3 oxide. This one is aluminium. This is iron. And this is aluminium oxide. Okay, all balanced already, huh? Okay, try to follow this. Okay, and this one gains oxygen, this one loses oxygen. Very simple. First one, it is a redox. No problem, huh? Okay. Jaden, try Jaden. Number 7. Jaden, are you there? Jalen, are you there, Jalen? Okay, Alicia, you try number 7.
This is a redox reaction.
Okay, that one no problem. No one. Okay, standard. Okay, number 2.
Iron 3 oxide is reduced to iron.
Iron 3 oxide is reduced to iron. Okay, settle. Next.
Aluminium is oxidized to aluminium oxide.
Okay, aluminium is oxidized to aluminum oxide. Okay, 3.3. Okay, now oxidizing agent.
Iron 3 oxide is the oxidizing agent.
Iron 3 oxide is oxidizing agent. Okay, which is the reducing agent?
Aluminium.
That's all. Okay, then we do the last one. Okay, and we go to this. No. I'll repeat again. H2S loses hydrogen. So that chlorine gains hydrogen. So you lose hydrogen. All right, is oxidation. This is reduction. Gaining of hydrogen is reduction. Okay. Last one, Joshua? Choo-choo train, try now.
Which one? The
Number 8.
right?
Last one.
This is a redox reaction.
Okay, this is a redox reaction. Good. Okay, carry on.
Hydrogen sulfide,
Is what?
is oxidized to sulfur.
Okay, well, hydrogen sulfide. Tadi I gave you the spelling, hydrogen sulfide, IDE, is oxidized to sulfur. Okay, next.
Chlorine is reduced to hydrogen chloride.
Chlorine is reduced to hydrogen chloride. Well done, Okay.
Hydrogen sulfide is a reducing agent.
Reducing agent, then?
And chlorine is an oxidizing agent.
Okay, that's it. So, we have settled for today. All right, we have looked at what is a redox reaction. We know what's the meaning of word redox. Both oxidation reduction taking place at the same time. And then we managed to write we managed to identify what is oxidized, what is reduced in terms of oxygen and hydrogen. And then we also managed to identify the oxidizing agent and the reducing agent from the left side. Okay, so with that, we call it a day today. So next lesson on Thursday, we will continue with the next part. Okay, any question for today?
Teacher,
Yes?
Al2O3, I thought is aluminium 3 oxide.
No, aluminum oxide. There's no aluminum, there's no 3. We don't use the 3 is only for for transition elements.
Oh, okay.
Okay, so aluminum oxide is just Al2O3. We don't say aluminum 3. Aluminum is only one charge. See? Okay, all right. Any question for today? No problem, Okay, so we call it a day today. Take care. All right, I will update the results today.
All right, thank you, Jia.